All right. Here's an example of an important pattern in factoring that's really good to know. It will save you so much time as you head into Algebra 2 and even pre-cal and so on. So let's take a look at these four different problems. They're all going to work by the same pattern for factoring, and it's a happy little shortcut for you. So it's a good one to know. Um, Think about what you notice here. What do they all have in common? Do you notice anything? Hit pause, really hit pause, think about it for a second. So maybe you notice that they all have subtraction, right? That is true. That's important. That's not a small detail. That's a really important detail. They all have to have subtraction for this pattern to work. And think about the numbers. 36, 25, a 4, a 9. Every single number here is a perfect square, even the understood 1 in front of this x squared here. If you think about 1 squared is 1, 2 squared is 4, 3 squared is 3 times 3, which is 9, 4 squared is 16, 5 times 5 is 25, 6 squared, 6 times 6, 36. 7 squared, 7 times 7, 49. There's all the numbers that we're seeing here. They're just all, mixed up, right? So this is called the difference of two squares because every single one of these has perfect squares in them. And so for the difference of two squares, you're just going to write two sets of parentheses. And by the way, you always look for a greatest common factor first, but if you don't have a greatest common factor, which none of these have a greatest common factor, then you're going to do the two parentheses and you're going to put the square root of the first thing. So, I mean, think about what's the only thing you can multiply to get x squared is x times x, right? There should not be a little dot there. Don't be confused. No decimal or anything. All right. And then the square root of 36 is, we just saw it over here, 6. And then you always put one with a plus sign and one with a minus sign. And that's the factored form. So it turns out that if we did the whole factoring process for x squared minus 36, we would end up getting these two factors. Same thing here. The square root of 4 is 2. X times x is x squared, so 2x. And then the square root of 9 is 3. And then one with a plus and one with a minus. That's it. Isn't that so much better than multiplying these together, together and getting factors that add up to, oh, there's nothing in the middle, factors that add up to 0, and then, dividing and doing all the things and eventually getting to this process, right? It's really nice when this works. So square root of 25 is 5. So 5x at the beginning, square root of 16 is 4. So 4 at the end, one with a plus, one with a minus. That's it. 8x, 8x, 7, 7, one with a plus, one with a minus. All right. So we've talked about this entire process and factored four different problems faster than we probably could have done even one of these the regular way. So just understand this only works when you have subtraction and when you have a perfect square at the beginning and a perfect square at the end. All right. I hope that helps. I'll see you next time.